All right, let's get into it. We're going to do a little visual investigation of this really interesting piece of hardware. I mean, at first glance, yeah, it's a drone. But the closer you look, you realize this is not something you can just buy off the shelf. So we're going to break it down and figure out what it is, and maybe more importantly, why on earth it was built this way. So here it is. And it seems familiar at first, right? But the longer you look, the more questions pop up. That design is pretty aggressive. The build looks totally unique. So let's just start with the biggest question of all. What makes this drone so special?
Yeah, it's pretty obvious this is not your everyday consumer drone. I mean, there are way too many propellers. The frame itself has this weird texture, and the whole thing just screams custom built. So our goal here is to figure out what all those differences actually mean.
Okay, to really get what's going on here, we have to deconstruct it. We're going to break down its physical parts, start with the basics, and then work our way up to what makes this thing so unique. So first things first, let's get a baseline. Most of us, when we picture a drone, we picture a quadcopter. 4 arms, 4 motors, 4 propellers. It's simple, it's effective, and it's pretty much the standard for a reason. Just kind of keep that image in your head for a second. Now, check this out. On the left, you've got our standard quadcopter, but on the right, that's what we're looking at today, an X8 Coaxial Octocopter. Now, octo means 8 motors, but wait, you can see it still only has 4 arms. So what's the trick? Well, they're stacking the motors, one right on top of the other. And that custom-built vibe really shines through right here. If you look really close at the texture on the frame, you see those fine lines? That is a classic telltale sign of 3D printing, and that tells us something huge. This thing isn't mass-produced. It's a prototype, built for a very specific job, where you need to make changes and test things out really, really fast. Okay, now let's zoom in on those arms. You can see the stacked motors perfectly here. This is what's called a coaxial setup. The propeller on top spins one way, and the one on the bottom spins the opposite way. And this setup, this is the key to the whole design. It's how you cram the power of 8 motors into the small, compact shape of a 4-armed drone. Which, of course, brings up the next big question. Why? Why go through all that extra trouble? Why do you need 8 propellers? I mean, think about it. You're doubling the motors, you're doubling the propellers, you're doubling the complexity. There's got to be a massive payoff for that, right? So what's the actual advantage of a design that's this complicated? Well, it really comes down to trade-offs. The huge pros are 1, just incredible power and lift. We'll get to that in a sec. And 2, motor redundancy. That means if one motor fails, its partner right below it can pick up the slack, and the drone can still fly or at least land safely. It's kind of like having a spare tire you can change in midair. But of course, the cons are that it's way less efficient, and naturally, it's a lot more complex and expensive to build. And here is that payoff we were talking about. All that extra power gives you a massive boost in lift capacity. We're talking an estimated 70% more than a quadcopter of a similar size. This thing was absolutely not built for taking selfies. This was built to carry something serious, like a heavy-duty cinema camera, a LiDAR scanner, or some other piece of very specialized gear. So, just when we think we've got this machine all figured out, the source material throws us a curveball, a new clue that kind of changes everything. See, it's not just one drone. And there you have it, a second, almost identical custom drone. Okay, now the plot really thickens. A single prototype, that's one thing, but a pair? That suggests a much more serious operation is going on here. So that brings up the next huge question. Why would you build 2 of them? If you're planning for some specific high-stakes mission, what's the strategic advantage of having a pair of these absolute beasts? Well, there are a few likely scenarios. The first one is the simplest. You have a primary and a backup. For those critical missions where failure is just not an option. The second possibility is for development. It's called A/B testing. You fly 2 slightly different setups to see which one performs better. And the third idea, which is maybe the most forward-looking, this could be the very beginning of a coordinated drone swarm where multiple machines work together to do one really complex job. Let's just zoom out for a second. What this whole investigation really shows us is a powerful trend happening in technology. This isn't just about 1 or 2 cool drones. It's about what they represent for the future. So what's the big takeaway here? These drones, they're more than just flying machines. They're a sign of a massive shift. With amazing tools like 3D printing and affordable electronics available to almost everyone,
We're moving from a world of consumers to a world of creators, people who can build their own custom tools to solve their own specific problems.
And that really brings us to our final thought. Seeing what's possible when this kind of technology is put directly into the hands of innovators leaves us with a question for you. If you had the tools and the know-how to design and build a custom drone for any purpose you could imagine, what problem would you solve?